Today we'll discuss salt hydrolysis. Pure water is a weak electrolyte and neutral in nature. That is, we know concentration of H plus ions is equal to concentration of OH minus ions in pure water. Because of equal concentrations of H plus and OH minus ions, it is neutral. When this condition is disturbed by decreasing the concentration of either of the two ions, the neutral nature changes into acidic or basic. When concentration of H plus ion is greater than concentration of OH minus ions, water becomes acidic in nature. When concentration of H plus ions becomes less than the concentration of OH minus ions, water becomes basic in nature. This is exactly the change which occurs during the phenomena known as salt hydrolysis. It is defined as a reaction in which the cation or anion or both of a salt react with water to produce acidity or alkalinity. We know salts are strong electrolytes. When dissolved in water, they dissociate almost completely into ions. In some salts, cations are more reactive in comparison to anions, and these react with water to produce H plus ions. Thus, solution acquires acidic nature. The equation is cation when it reacts with water forms weak base along with H plus ions. These H plus ions are responsible for acidic nature. In other salts, anions may be more reactive in comparison to cations, and these react with water to produce OH minus ions. Thus, the solution becomes basic. The equation is anion A minus. It reacts with water and produces weak acid along with OH minus ions. These ions are responsible for basic nature. Thus, if acid is stronger than base, solution would be acidic in nature. If base is stronger than acid, the solution would be basic in nature. And if acid and base both are equally strong or weak, solution would be neutral. Now we'll talk about types of salts. As per the nature of cation or anion, salts are divided into following categories. Salt of strong acid and weak base, Examples are FeCl3 consists of FeOH whole thrice, which is a weak base, plus HCl, which is a strong acid. When these two react, FeCl3 is formed. CuCl2 formed by the reaction of CuOH whole twice, which is a weak base, along with HCl, which is strong acid. AlCl3 formed by the combination of AlOH whole thrice, weak base, along with HCl, strong acid. CuSO4 formed by the combination of CuOH whole twice, weak base, and H2SO4, strong acid. The next type of salt is salt of strong base and a weak acid. Examples: CH3COONA formed by the combination of CH3COOH, weak acid, and NaOH, strong base. Another example: NaCN formed by the combination of NaOH, strong base, and HCN, weak acid. Another example is NaHCO3, sodium hydrogen carbonate. It is formed when NaOH, a strong base, reacts with H2CO3, weak acid. Next type of salt is salt of weak acid and weak base. Examples: CH3COONH4 formed when CH3COOH, weak acid, combines with NH4OH, weak base. NH4 whole twice CO3 formed when NH4OH, weak base, reacts with H2CO3, weak acid. And the last type of salt is salt of strong acid and a strong base. Example: NaCl. It is formed when NaOH, strong base, combines with HCl, strong acid. Another example, NaNO3. It is formed when NaOH strong base combines with HNO3 strong acid. Now some important formulae related to salt hydrolysis. For the type of salt consists of a strong base and strong acid. The nature of solution would be neutral and it won't undergo any hydrolysis. So for the salt consists of weak acid and strong base. The nature of solution would be basic. The degree H would be under root Kw upon Ka into C. Its hydrolysis constant Kh would be Kw upon Ka, and pH would be equal to half pKw plus pKa plus log C. Then for salts consist of weak base and strong acid. Nature of solution is acidic. Degree is equal to under root Kw upon Kv into C. And hydrolysis constant Kh would be equal to Kw upon Kb. And pH would be equal to half pKw minus pKb minus log C. And for the salt of weak acid and weak base, the nature depends on the nature of Ka or Kb. Degree would be equal to under root Kw upon Ka dot Kb. Hydrolysis constant Kh would be equal to Kw upon Ka dot Kb, and pH would be equal to half pKw plus pKa minus pKb. Here H is degree of hydrolysis, Kh is hydrolysis constant, Kw is ionic product of water, Ka is dissociation constant of acid, and Kb is dissociation constant of base. In case of weak acid and weak base, nature of medium is decided as follows. If value of Ka is equal to Kb, then neutral medium. If value of Ka is greater than Kb, then acidic medium. And if value of Ka is less than value of Kb, then basic medium.